Welcome. This is question number 59 from the Giancoli textbook, chapter 6 on work and energy. We have a question about power, cars traveling at a constant speed down the highway at 88 kilometers per hour. That sounds pretty fast, but remember it's in kilometers per hour, so we're going to have to do some conversions. This should have flagged you right away that these are non-standard units. We're going to have to deal with this. And the same thing is true with the power that's given to us. We're given the power of the car's engine at this moment traveling at a constant speed in horsepower. We're going to have to make this conversion. Before we get to those conversions, let's just talk more generally about this concept of power. Remember that power is equal to a rate. It's the rate at which work is done, or it's the rate that energy changes with respect to time. Let's also keep in mind that by definition, work is equal to force times distance. Now, technically, there's the trig component here of cosine theta. I'll deal with that in a sec. And the force of the car's engine is in the same direction that the car is going in. So the angle theta in between the direction the car is going in, the direction the force acts, is 0 degrees. The cosine of 0 is 1. And so it's not that we're going to ignore this piece, but it doesn't affect numerically our results. So we get force times distance over time. You should recognize that distance over time is velocity. So I can also write this as force times velocity if I tease out the distance and the time component. So this kind of definition of power as being force times velocity becomes useful in questions like this when an object is moving with a constant speed. And so I'd really encourage you to kind of think about that. Think about using this when something's moving at a constant speed. All right, I'm ready to go. I have power, I have velocity, and I'm looking for force, right? So I can just divide both sides by V, and I have an expression for the average force exerted by the car's engine. But these numbers aren't going to work for me. I have to convert them. I'm going to have to convert speed into meters per second. And when I do that on my calculator, I get about 24.44 repeating meters per second, right? So this is something we've seen before. And also, I need to know that 1 horsepower is the equivalent to 746 watts. So in order to get this power expressed in standard units, SI units of watts, I'm going to have to multiply 18 by 746, and I get 13,428 watts. So I'm going to put that number here, 13,428 watts. And I'm going to divide that by the speed of the car, 24.44 meters per second, and I'm going to get my average force. Once I plug that into my calculator and truncate for significance, I get an average force of 550 newtons for this problem.